Hey Precalculus. So in 2.2 we're talking about graphs of functions, and one of the first things that I wanted to point out is that not only can we find the domain and range of a function algebraically like we did in our 2.1 notes, we can also find it graphically. So to do this, obviously we're going to have to graph. So for the first problem, I'm going to go to my y equals in my graphing calculator and plug in the square root of 4 minus x squared, making sure to, oh, I guess on my calculator I don't need a parenthesis there. Okay, so there's 4 minus x squared. On some of your calculators, if they're a little bit older, you might need to put parentheses around the 4 and after the x squared. And now I'm going to go ahead and graph this. So I get the little top half of a circle here. Now, because this is a rectangular window, but my pixels aren't necessarily rectangular, it's a little bit squished. If I want it to look more like half of a circle, I would hit zoom and then square. We'll adjust my window to make it look a little more circular. And if I want a better picture, I can also zoom in. That'll give me a little bit better picture. Now, on this picture, it looks like it's not actually connecting. It looks like it's not actually hitting the x-axis on either side. However, it really is. Your calculator's just hitting rounding errors right here. So you should know that when you graph the picture of this guy on your paper, let's see, oh man, that x-axis is all squiggly. So if I go out, let's see, it's 2 in either direction and 2 up. When you draw the picture of your graph here, make sure that it connects with the x-axis, even though it doesn't look like it does here. Now you can tell that it really does hit, because if I plug in x equals 2, 4 minus 2 squared, well 2 squared is 4, 4 minus 4 is 0, the square root of 0 is 0. Also in my xy table, when I plug in 2, I get 0. So I know that really does hit. And then at -2, and this is too high. Okay. So if I'm going to find the domain and range graphically, what I do is I look at the picture and I say what x's, that when I plug in an x, I'm getting out a y coordinate. Well, the x's are happening from -2 to 2. So there's my domain. And the range is happening from 0, because 0 is the lowest y value I'm getting, up to 2. So my range would be from 0 to 2. Okay, so just by looking at the picture, I can tell what the domain and the range of this graph are. Now I can do the same thing for part B. So I would go back into my graphing calculator, clear it out, and I need to plug in 2x divided by x minus 3. Notice that I'm putting parentheses around the top part of the fraction and the bottom of the fraction, the numerator and the denominator. I'm going to hit zoom 6 to go back to a standard window. And here I'm getting the graph of a hyperbola. Now on a hyperbola, there's some values that your graph is going to get closer and closer to and never touch. Those are your asymptotes. And so I'm getting an asymptote, a vertical asymptote here. Well, we know from the other day that I can't plug 3 in because that would give me a 0 in the denominator. And if I go to my table, I can also see that 3 is the error. So I can tell from the graph of the picture that this graph is never going to hit 3 for the x. And then for the y, if I wanted to look and see what my graph is getting closer and closer to but never actually touching, I could go into my xy table, and if I just keep scrolling down, you're going to notice these y values are getting closer and closer and closer and closer to 2, but they're never actually getting to 2. Even at like 58, it's not getting to 2. And I could go ahead and change my table set. I could start my table at 0 and make it change by 100. So now my table is going to scroll faster. And notice as I'm scrolling through, it's still never getting to 2. It's never actually going to hit 2. So what my graph would look like for this problem is I'm going to have an asymptote at 3 and an asymptote at 2. So let's see, at x equals 1, 2, 3, I have a vertical asymptote because x can't equal 3. And at 2, 1, 2, I'm getting a horizontal asymptote at y equals 2. And then the curve of my hyperbola, let's see, I'm getting one branch in this corner, it looks like, and another branch up in this corner. So here would be one branch of my hyperbola. It goes through 0, 0, and my other branch would be up here. Okay. So as far as domain and range go, if you look at the picture, my domain for this problem are all numbers except for 3. So I would say negative infinity to 3, union 3 to infinity, to exclude 3. And then my range for this problem would be all numbers except 2, so negative infinity to 2, union 2 to infinity. So just by looking at the picture of the graph, you can tell what your domain and range are without having to do anything algebraically, which is kind of nice. All right, for the second example, graphing a piecewise function, we talked about this today in class. I'm going to get 3 different pieces of graph here, which is why it's called piecewise. And the if statements are telling me when to graph each chunk. So for instance, if x is less than negative 2, here's negative 2, I'm only going to graph 4. So I'm going to go up 1, 2, 3, 4, and I'm only going to graph 4 until I get to negative 2. Now when I get here, I have to decide whether I want it to be a closed circle or an open circle. And since this is strictly less than, I'm going to put an open. Then between negative 2 and 2, I'm going to graph the parabola x squared. So let's see, between negative 2 and 2, the parabola x squared starts at 0, 0, because 0 squared is 0. 1 squared is 1. Negative 1 squared is 1. Negative 2 squared is 4, so 1, 2, 3, 4. Now since this is an equal to, it's going to fill in that circle. And then 2 squared is 4. And since this is an equal to, it's going to fill in that circle. Okay. And then negative x plus 6 if x is greater than 2. Now, up until this point, graphing was pretty easy because I know 4 is constant. I know x squared is a parabola, so that wasn't too tough. Negative x plus 6, though, I know this is going to be linear. I know the slope's going to be negative 1 and the y-intercept is going to be 6. But since we're not starting on the y-intercept, I'm going to make an xy table. So I am going to plug 2 in, even though 2 isn't greater than itself, because I need to know what happens when we switch at 2. So let's see, negative x plus 6. So negative 2 plus 6 is 4. So I actually do get a point at 4. And then at 3, let's see, negative x plus 6, so that's negative 3 plus 6 is 3. So I go over 3 and up 1, 2, 3. And from here, since I know I have a negative 1 slope, I can just keep going down 1 over 1, down 1 over 1 to continue graphing. And so there's the third piece of my piecewise function. The last thing that we're going to talk about is what to do when you're given a piecewise function and you're asked to find the graph, which is a little bit trickier. So first you want to identify your boundary points. Now let's see, this is 1, 2, 3, so this is negative 3. So I know I have something happening if x is less than negative 3. And then between negative 3 and 0, I'm getting a point. So if negative 3 is less than x is less than 0, because 0 is right here. And then it looks like when it's bigger than 0, I'm getting my third chunk of graph. So if x is bigger than 0. Now because this is filled in, I know this is greater than or equal to. And let's see, this one's open, so this 0 is open. This one's filled in, so it's an equal to here. And this one's open, so it's not. Okay. Now, let's see. It's a constant function here. It's not going up or down. It's just a straight line. So that one's easy. Negative 1, negative 2. So if x is less than negative 3, then I'm graphing negative 2 with no slope. So this is just a negative 2. This is a line. Let's see. This line has a positive slope of up 1 over 1. So I have a slope of 1. And it has a y-intercept of 2. So this would be like the line y equals 1x plus 2 right there, because the y-intercept is 2 and the slope is 1. Since the f of x is already standing in for my y, I'm just going to say x plus 2. And then this guy looks an awful lot like a parabola. You can tell because parabolas, if you go over 1 and up 1, and then you go over 2, up 4, 1 squared is 1, 2 squared is 4. So this is following a parabolic arc. And it's a parabola that's been shifted down 3 units because its y-intercept is down 3. So it's the parabola x squared shifted down 3 units. And there's your piecewise function. All right, guys, for practice problems tonight, would you please, on this set of notes, do page 168, number 42, and number 54. and then do page 167, number 32, 34, and 36. Please make sure for these practice problems that you're writing down the original information, what's given in the textbook, and you're showing all of your work. We're going to check the answers to these practice problems and the ones that we did last night in class tomorrow. Thanks, and have a good night.